Hi, let's talk about applications a little bit. An application is where the technology gets used. What makes a good application? Well, intuitively, a good application is one where the requirements of the end users are going to map to what the technology provides. Where do these requirements come from? Well, as we've seen, the technology is going to be used in a practice, which is a goal-driven activity that's repeated over and over again. Inside that practice, there's going to be some tools we're using already and that we're invested in. Those are sunk costs. We don't want to throw them away until we have exploited their useful life. There's some people that are doing the activity, so we want the technology to meet their skills and things like that. And we want some outcome out of the activity, because otherwise, why are we doing this over and over again unless we're a little mad or crazy? Or we're just doing it for fun, but that is the outcome. So here's a ball. And notice this ball, I can push it together pretty easily. It's actually a kind of beach ball. And the second I say beach ball, in your mind, you're picturing a kind of plastic, a softness to it that doesn't exist if I was to say soccer ball or basketball, which are much harder. If they hit you in the head, you go, wow, that really hurt. So intuitively, you can see that when we're trying to figure out an application for a technology, in this case, our ball, what we're really doing is saying, if my end user has these kind of requirements, I want to find an application where the performance of my technology maps or clusters tightly around what the end user needs in order to accomplish their activity. The more tightly it clusters, the better the goodness of fit for the application. Now, obviously, you'd like to cluster above rather than below the requirements for the application. You're clustering below, then the question is, can I stretch my performance so it's useful or not? On the other hand, if I'm way above what the end user needs, I'm likely to be too expensive. If I'm not, that may be interesting. Or if I'm way below, it underperforms, then who cares? So a good application for this ball is one where the performance of the ball maps to what the end users are looking for. I'm looking for a ball that I can play with little tiny children. This maps to it. It's soft, it's big enough for them to kick or push or whatever, and they're not exerting enough force on it in order to break it. The price is right, and it's very, very easy to use. So it works as a toy for grandchildren. It's really not too much different when you're looking for an application for your technology. You're still doing the exact same kind of stuff. You're saying, given all the potential applications I can go into, where does my technology's performance map most tightly to the performance that the end users are looking for? I can weight it and make it all, fancy if I want, but basically I want to cluster around what they're looking for and always be able to attain that either today or by stretching the technology. If I can find that sort of sweet spot, then I have an application for my technology. I can begin to winnow those down to select the best one. The best one's going to be the easiest one to enter. Why do I say the easiest one to enter? Because if you have a new technology and it's going to market for the first time, the real problem is how to get cash flow going, how to get that first sale, how to get things moving. Once it's moving, you can expand out into other markets and so on and so forth, because now you got some cash to spend. But in the short term, your problem is commercialize, and commercialize means get that first sale. Okay, when we come back, we'll look at applications in more detail.